Hi, welcome back to Manohar Academy. In this lesson, we are going to learn about the superclass object. Previously, we have seen how to create derived classes. In all these lessons, we have created subclasses from the person class. So we have created a student from person. We also created employee from person, and also at one time we mentioned employee can be further extended as something like manager. These are all examples. So let me show you those things in the IDE. So these are the classes we have been seeing previously. Here in the employee is extending from person. So here we are calling the superclass constructor. Also here the student is extending from person and we are calling the superclass constructor here to set the first name. Also in the previous lesson we mentioned that in every constructor on the first line we should either call superclass constructor or a different constructor in the same class. So this is what we mentioned. Is that true for the person also? Because here if we see the person class on the first line we are not calling superclass constructor, also we are not calling any other constructor in the same class. But the statement that we made that in every constructor on the first line we should call either superclass constructor or a different constructor in the same class is true here. So the compiler is going to insert this particular statement. So we may ask, what is the constructor that we are calling here, right? I mean, the person is not extending any class, so the superclass constructor invocation is not giving any errors. So what is happening here? So actually the person is extending a superclass called object. Every class derives from object. So if you don't write extends, it is actually extending from object, and that is implicit. You don't need to mention that. So here in this slide we can say, even though we are seeing the hierarchy in this way, the actual hierarchy is object to the person to the student, or object to the person employee manager. So this is the real hierarchy, the class hierarchy. So the object is superclass or cosmic superclass. Every object derives from the class object. So the name itself is object, so don't get confused. As person is a class name, so is object is class name. Here you can see the O is capitalized. Because of that, every object is going to inherit some methods from the object class. In the previous lesson we have seen that whenever we are creating derived classes, they inherit all those methods. So because every class is inheriting from the object, every class is going to inherit all these methods. The first three methods, these are very frequently used, and these three are rarely used or used sometimes. And the five methods here, the five versions of two methods, that is wait and notify, they will be used in case of concurrent programming. We are very long way from learning about concurrent programming, so we don't worry about these five methods at this time. So coming to finalize, we know about garbage collection. So before the object is garbage collected, the finalized method will be invoked on that particular object by the garbage collector. But because we don't know when the garbage collector is going to collect that object, we don't want to depend on finalize method at all. So even though finalize method is there, it is very less frequently used. And getClass will give the class name or the class of that particular object, and this is also rarely used. In case of reflection, it is very widely used, but generally it is not used that much. And clone will create a clone of current object. This will create a different object with the same state, but the depth of cloning will depend on how it is implemented. Also, we are going to cover the clone in a different lesson. I am not going to cover it here. Even though we dedicate a separate lesson for clone, still it is less frequently used. Okay, coming to the three important methods that are toString, equals, and hashcode. We have been seeing the toString from the very first lesson on classes. Okay, let's see toString one more time. Here we have a class called test class. It is in so and so package, and here I am creating a object of that particular class and I am printing that object. The println, whenever the object needs to be printed, it will be converted to string by calling its toString method. The inherited method have default behavior, that is, it is going to print the complete or fully qualified class name, in this case package name plus class name, that is the fully qualified class name, at the rate of some value. So it is generally hash code or something. We don't need to worry about that. Okay, but this is very less useful. Whenever we want to print some object, we want to print its state or some useful information, but not just its address or something like that. So to do that, we are going to override the toString method that is inherited from the superclass object. Okay, here I have overridden it, but I'm simply printing modified behavior of toString method. I am not printing any field values. Also, I haven't created any fields here. So if in this time, if I print the object of type test class, I'm going to get the message from this toString method. Okay, so the toString is used to modify the behavior that is inherited, and also toString is used to print the message in a convenient way so that we can know something about the state of the object. Okay, toString is very simple. You just override it. Whatever message you want to print, you will return that string. Coming to equals and hash code. Before we discuss that, let's look at two classes. One is myDate. It is going to have year, month and day of month. Another is student class. Student is going to have first name, last name, date of birth. Now I am creating two objects. Both are going to have 2017 January 1st. So I have two objects here of type myDate. And I'm going to create two students, and both are going to have same first name, same last name and same date of birth. We know that date 1 and date 2 are pointing to different objects because we have created two objects. Here we are creating an object, here also we are creating a different object. They are pointing to different object. So are student 1 and student 2. Here also we created two objects. So student 1 and student 2 are also pointing to two different objects. But I can say that date 1 and date 2 are equal because both are referring to a date called January 1st, 2017. I can surely say that there is only one date, that is January 1st, 2017. But I cannot say that student 1 and student 2 are same or equal. I can't say that because even though they have the same first name, same middle name or same last name and same date of birth, I may be referring to two different persons. So here, in one case I can say with confidence they are equal, and in another case I can't say whether they are equal or not. That is because these are value based objects. Their state is nothing but a value of some date, some currency value, something like that. But here we are talking about two different entities that will have some behavior. Also, if you want to learn more about value based objects, something like date, go to this particular Oracle document, just search for value based classes. You are going to get to this page and you can read about this one. So here they are considered equals basically based on the equals method. We don't compare the identity of those objects. We simply get their equality by calling the equals method. That's the reason I am mentioning this here. Okay, so we are seeing two different kinds of classes. One is value based, another is not value based. Okay, so whenever we are overriding equals method, we have to take some steps. Okay, instead of showing it here, I am going to show you that in the IDE so that it will be properly indented, also properly color coded. Okay, here I have the same class myDate. Here I have myDate class and it has three fields. So if I want to override, remember that the object you are receiving is going to be referred by a variable of type object. It can't be myDate. If it is myDate and the signatures doesn't match, in order to override the signatures has to match. Because of that reason it has to be object, because that is how it is defined in the superclass. Okay, first of all, if the received, okay, what are we comparing? We are comparing the current object, that is nothing but referred by using this keyword, to another object that is passed to equal methods. Okay, so here I can show you that what happened here. Okay, I removed that constructor. Okay, I have two dates here. I'm calling to date1 dot equals date2. So this is how we call equals method, right? So we are comparing date1 with date2, and date2 is received as a different object or other object. So if the other object is null, then we can't compare them, we should return false. If they are same, because if the identity is same, obviously they are same, we will return true. Then sometimes before comparing their state by field, we want to make sure they are of the same class. For example, if we want to compare two students, we want to make sure their class is same. We have seen that getClass will return the class. So we want to make sure the current object class is same as whatever object we received. If they are not of the same class, we are going to return false. It comes handy in case of inheritance, like we don't want to compare students with employees, or even we don't want to compare a person to a student. In those cases we can do this, or in some cases we may simply need to make sure the received object is instance of some type. In this case we are just checking that whatever other object we received, it is of type myDate. So if they are of different type, or if the received object is not of myDate type, I'm going to return false. So if all these statements are true, I mean if we don't get a false statement by this time, then we can cast whatever object we received to the myDate type, because here the class is myDate. So this is the class cast expression. I'm going to discuss it in a different lesson, but for now just remember that whatever object I received, I'm typecasting it, then I'm comparing field by field. I'm comparing year to year, month to month, then date of month to date of month. If they are all same, then I'm going to return true. So this is how we override equals method. There is some more to the equals method, that these are the technical details. Like we don't need to know their names, but it is reflective, meaning x dot equals x should always return true, because a object is equal to itself. It is symmetric, meaning if x dot equals y returns true, then y dot equals x also should return true. This is transitive. If x dot equals y returns true and y dot equals z returns true, then x dot equals z also should return true. So x is equal to y equal to z, then x should be equal to z. That is what transitive means. In case of symmetric, if a equal to b, then b should be equal to a. In case of reflexive, it is a equal to a. That's it. Also, it should be consistent. For that reason, we are going to take care of those null values and all those things. Also, when we say consistent, it should be consistent across invocations. Like if the state did not change, then if we call that method any number of times, it should return the same value, either true or false, but it should be consistent. Also, null reference, we talked about that. X dot equals null should return false. Are we done with equals method? No, not yet. Whenever we call the hashcode method on the object, it is going to return the hashcode for that particular object. What is hashcode? We'll see, don't worry. But the important thing is, whenever we are overriding equals method, we have to override hashcode method. That is the contract. That is because, why is that important? Because whenever x dot equals y return true, then x dot hashcode and y dot hashcode should also return the same values. Meaning two equal objects, in this case x and y, should return the same hashcode. So x dot hashcode and y dot hashcode should be same. Having said that, two unequal objects may return the same hashcode. That is okay. But our target is, as much as possible, that different objects should return distinct values or different values. But we don't have any restriction on the different objects, they may or may not return the same hash code. We don't have any contract there. But if two objects are equal, then they should return the same hash code. That is the contract. So that is what I meant by we are not done with the equals method, because the moment we are overriding equals method, we also have to override hashcode method. Okay, that is all about the superclass object. The class name is itself is object. So to recap, we are going to inherit these methods, 5 methods that are related to concurrent programming. We are not going to touch that. 3 methods less frequently used. One is to get the class of the object. One will be called when the garbage collector is going to destroy the object. Another is to create the clones or different objects with the same state. The most important and highly used methods are toString. This is used absolutely all the time whenever you want to print some useful message, and equals and hashcode, they are also modified whenever we need to check for equality. Okay, that is all from my side. I hope you have learned something from this class. Last but not least, if you haven't subscribed already, please go ahead and subscribe so that whenever I upload some videos, you are going to get the alerts. Also, if you are benefited from this video, please make sure you like this video and you share it with your friends so that they can also watch, they can also learn. Thank you. See you in the next lesson.